This conference will now be recorded.
It starts. So already we have taken a task of a small game. Okay, please come fast. Sit fast. I'm waiting. So already you have seen how to prepare data for that. Okay, directly how to create and how to read data from the file. Already we know that part. Okay, three styles we have seen. Now here manually I'm creating those things. For same our environment, we are creating one environmental matrix. Know that this has three spaces. Row states, columns are actions. Okay, each cell value is a reward. But in our yesterday code, we have used np.array. Yeah, there is a special function here, matrix. So what is the difference between np.array of double dimension, np.matrix of double dimension? So what is the difference? First we will see the technical part. So first I'm importing numpy. Same thing I'm taking it as np.array. First, what is the difference you just mentioned? See here, R is matrix, created as matrix, E is created as double dimension numpy. I'm start working with E. First you tell me I want fourth row, third column. You have to give, if it is double dimension, you have to give two indices. First for row index, second for column index. Fourth row means what is the index number? 3. And the third column I want, index number 2. Okay. I want completely third row or completely second column I want. In the place of row index, if I say column, it takes all the rows. Okay. Come on. 2 means what are the values, sir? -1, -1, -1. Sorry. -1, -1, -1, 0, -1, -1. Observe the output. What is the dimension of the input? Input is E. What is the dimension? Double dimension. So can you close the door? Other classroom voice is coming. Okay. So E is a double dimension. Whenever I have taken one single column, or a single row, I got a single dimension. Observe the shape. There are 6 elements. That is a single dimension. You can apply even NDIM also. That is a single dimension. Door close, please. Observe this. In the place of R, the place of E, I am giving R. R created as a matrix. What is the dimension I got? Double dimension. What are the values of it? You just check it. There are 6 rows, 1 column. Understood the point, the difference. If it is double dimension NumPy array, if you take any single column or single row, you get a single dimension object. If it is matrix, if it is created as matrix, even if you take single column or single row or single column, you get double dimensional. If you want to give shape, what is the shape of it? 6 rows, 1 column. Because our entire Q-learning calculation is based on the matrices. That's why if you take one subset, that also should be a matrix. That is the reason instead of creating as NumPy array, created as NumPy matrix. All of you understood the difference? First you take the sample, don't take all the data. Just R equal to np dot matrix of. Take 1 or 2 rows and remaining set dots. Just 1 or 2 rows enough. Now take explanation for that. Write down this difference between NumPy double dimension array and NumPy matrix. When you access single column or row from 2D array, returned object is single dimension. If it is accessed from matrix, returned object will also be a matrix. Think that E is a array or is a matrix. E of all rows, suppose second column I am asking. I'm applying dot shape of it. I get 6 comma, that's it. There is no column dimension. That means it's a single dimension. The same thing I am using for the R, which is a matrix. The shape will be like this: 6 comma 1. That is 6 rows, 1 column. Still, it is a matrix. All of you understood the difference? On the same style. Now here R is your environmental matrix, which has the rewards. Totally 6 rows, 6 states, 6 actions, of 36 values into that. Whenever it achieved the goal state, 100 is the reward. Whenever there is a vacancy but no result, 0 is the reward. If there is no vacancy, -1. Now the next step, you are going to create the knowledge matrix, because you need two matrices. Observe this. Yesterday we said np dot zeros of directly 6 comma 6. So that is just a number array of double dimension. Now we are converting that double dimension array into the matrix by using np dot matrix. Now R is a matrix, Q is also a matrix. When you access some sub-elements from that, a returned object will also be a matrix, because our calculation is based on the matrices. Check all the values of this one. All values initially zeros. After completion of training, the values got filled. Come on, take this, a second step. Okay. The next step, you are fixing a learning parameter here. What is that learning parameter? I will give explanation. Let's say gamma is equal to 0.8. Write the explanation for that. Gamma. That is just a symbol. It is a learning parameter. So what is the importance of this learning parameter is what you are expecting from the agent while learning. Like heroes, please listen. What you are expecting from the agent during the learning. That is during training process. Whether you are expecting short-term reward or long-term reward. Understood the points? If you are expecting short-term reward, the value should be close to 0. If you are expecting long-term reward, value should be close to 1. That means the value range should be greater than 0, less than 1. In between 0 to 1, the value should be. Suppose here, what is the value we have given? Gamma equal to 0.8. 0.8 close to 1. Close to 1 means we are expecting long-term reward. Understand the points? So in our game example, what you are expecting? Short-term best or long-term best? Hmm? Short-term best or long-term best? When our goal state is fixed, always long-term is best. Understand? Suppose imagine, all of you imagine the room structure number 3, sir. From the room number 3, in which rooms that you can enter? You can enter 2, you can enter 1, you can enter 4 also. Understand? Final target is achieving the 5. Understood the point, sir? Just to step into 1, step into 2, step into 4 is not our target. In a better way, with a better policy, it has to achieve the final goal state. In so many ways that it can reach. Understand the point, sir? But which should be the best way? Finally, you are expecting that one from the agent. That's why long-term reward is preferred. Understood the points? For example, imagine the same room structure, all of you. If you forget the room structure, I cannot help you, sir. In that room, think that in the room number 4, there is a tiger. Room number 1, there is a snake. Understood? After room number 1, there is a 5, which is a goal state. Understanding the point, sir? If it is the moment, if tiger is going to enter into the number 3, in this moment, which is the immediate right movement, right action. So you are confusing. I will take a picture again. This is what my room I have given already. The room numbers are like this: 0, 1, 4, 3, 2. Where there is vacancy here? 0 to 4 vacancy, 1 to 3 vacancy, 3 to 4 also, 3 to 2 also, 1 to 5, 4 to 5. This is the vacancy. Suppose I am here now. There is a tiger here. Your agent is here. That means you. There is a snake here. Think that these tigers, snakes are moving from one room to other room. A dynamic environment. It's not static. A dynamic environment. That means tigers, snakes are moving from one room to another room. At the same time, you are here as a agent. Actually, to achieve number 5, what are the best ways? If you are in 3, 1, 2, 5, 3, 1, 5, that is one way. 3, 4, 5, that is another better way. Your long term is based on this one. This is what like long term reward. Understand the point, sir? But in this moment, I don't want long term. Immediately, I need survivability. Understand the point, sir? Think that the snake is going to enter into room number 3. Now, in this moment, which is the best? Immediately step into 2, short term reward. Sometimes we need to compromise for short term. Getting my point,
But
sir?
usually,
Because immediate survivability is required. Like, suppose it entered into 2. After that, if really snake also entered into number 2, we cannot do anything. Game over. Suppose taken as a agent entered into number 2. Immediately, snake and tiger entered into room number 3. Tiger killed because of the snake. After that, the snake luckily did not see the 2 and stepped into number 4. Then you can come out to number 3, and then you can choose number 1, and then you can choose number 1. Understood the points? On that way, during training, what you are expecting from the agent? A short-term reward or a long-term reward? Based on that, we have to decide the gamma value. Understood the point, sir? Write down this. Gamma is a learning parameter. Value ranges greater than 0 and less than. Don't give 1, don't give 0. Between 0 to 1, you have to give. If gamma is close to 0, what's the meaning? Use priority for short-term reward. If close to 1, use priority for long-term reward. Now look the value. What is our value? 0.8. Okay. Now I'm going to start training. Before training my agent, we need to prepare some functions. I'm taking one variable called initial state. So initial state is what here? 1. That means in the room number 1 we are keeping. You can start. You can choose any initial state before you start training. Initial state room number 1. If you are in room number 1, what actions that agent can do? How agent knows? For that purpose, we are defining one function. All of you, look at your values. Not by seeing the picture, by seeing the matrix, how you know, how your agent knows what values can be possible, what actions can be possible. I am at room number 1. What actions are possible? All -1 means that not possible, right? Which is not -1? Possible. That means the value which is greater than or equal to 0. Those are the possible actions. Understood? Observe this. 0 possible action. If I am in room number 1, what actions possible? 0. 0 for which action? 3. And 100 is a possible action. 100 is for room number 5. Understood? So I don't want these values. I want index number of those values. How to take that index number? This. Small practice here. I'm taking the values I am giving np.array -1, -1, -1, 0, -1, 100. Look at only these values. I'm giving a condition. A dot where. A is an umpire. For that where you are applying. In the where as input you have to give some condition. The condition I am giving where your value is greater than or equals to 0. For which indices the condition is true, the index numbers it will get. Understood? Okay, before going for this where, directly if A is an umpire, A greater than or equal to 0 I am giving. Understood? What is the statement you just observed? For which values the given condition is true, those values it is correct. Are you getting this one or not? But a dot where of a greater than or equals to 0. Now it returns me index numbers. NP ND array has no object called NP dot array. Numpy NP dot where. Now check it. What is the meaning of it? The given condition is true at third index, fifth index. That means in our term, where actions are possible. If I am at room number 1, what actions are possible? That I can enter into room number 3, that I can enter into room number 5. Understood the point, sir? By applying this logic, your agent will know what actions will be possible from a particular room. Understood? So for this purpose, we are defining one more function here. The function is available actions. I am passing my initial state. That means current state I will pass. First to take this line by line, we will understand about this statement, this function. Before that, put the heading function for finding available actions from a particular state. First to take this function. All of you completed. Can I go to next? Okay. Not the next. What exactly happened in this function we will see first. Step by step we will see. This is my answer, which is the environment matrix. Let's access only one row, first row. So that means initially I am keeping state value as 0. Okay. I want to take only that row, sir. Only that row. Let's say states. R of which row you want? State. One column set. R is a matrix or number? Matrix. If it is a matrix, even though you access single dimension, even though you access a single row, you get another matrix. Just look at the state's value. What is the size of it? 1 by 6. One row, 6 columns. Got it? Okay. Now this is what my thing. Now I am applying a condition. Np dot where states greater than or equals to 0. That means -1 means action not possible, not possible, not possible, not possible. Here 0 means possible. But I don't want that 0. I want index number of that 0. What it has given. Confused? The first one is for row index. Second one is for column index. That means in row index 0, given condition is correct. At the same time, in the column index number 4, the given condition is true. That means what is the exact location of the 0? Exact location of the 0. 0, comma 4. Where is your required information? In row index or in column index? Column index. That is the second element, right? That's why we said second element means index number 1. Now you check it. Understood or not? This thing. Okay, sir. Come to the room number 1, sir. Room number 1. What actions are possible? 0 and 100. 0 for 3, 100 for 5. Just I am changing. Run the same thing. If I am in room number 1, what actions are possible? 3, 5 are possible. If I am 2, first tell me before seeing the output. If I am in 2, what actions possible? Only 3. Now I am going to room number 3. What actions possible? 1, 2, 4 possible. Check it now. Sorry. 1 to 4. I am in room number 4. What actions? 0, 3, 5 possible. I am in number 5. What actions possible now? 1, 4, 5. Okay, 5 to 5 also valid action. But 0 to 0, 1 to 1, 2 to 2, 4 to 4, invalid actions. But 5 to 5, valid action because 5 is the gold state. Now you check your function now. What happened? I am passing state number as a argument here. That particular row I am taking. If I pass 0, all 0 related actions we are taking. From that, which values are greater than or equal to 0 we are taking. Our required information in the column indexes. That's why of 1. Finally, we are returning that array. All of you understood what we have done. Now I am keeping this space. Now let's check with the function. The function created now. Let's say available actions. That means possible actions. Of initially 0, sir, I am passing. If I am in 0, what actions possible? Available, spell mistake. What actions possible? Only 4. I am coming to number 1. What is 1? Tell me. 3 and 5 possible. If I am in 2, only 3 possible. If it is 3, 1, 4, 2 possible. And 4, 0, 3, 5. And if you are in 5, 1, 4, 5. That means your function is identifying possible actions now. Okay. So let's check for each and every one. How many states we have? For I a range of negative generate or dot share of 0. That means number of rows it is taking. What is the number of rows? 6. Range of 6 means 0 to 5. In the first iteration 0, second iteration 1, like that up to number 5. Print state 1, state I. Possible actions. What is your function here? Available underscore actions. In the place of state I am passing I as argument. Check it now. State 04, state 135, state 2, 3. Look at last 4, state 4, 035. These are the possibilities. So on that way, your agent knows what are all the possible actions, what are all the impossible actions. Okay, come on, take this for loop also. Don't take output only, take the for loop. Okay, sir. Sir, look at state number 3, sir. What are the possible actions? 1 to 4. Suppose if you are in room number 3, if possible actions are 1 to 4, at a time, how many actions that you can perform? Only one action. That is among 1 to 4, any one action to be selected randomly. Not all the actions at a time. Because agent cannot perform multiple actions at a time. That is not one action. But possible actions are more than one. So for that there is another statement. Observe this. NP dot choice of. Okay. What is our function name? Available underscore actions. Let's say you are in group number 3. Got it? I'm asking one. Check what happened. NumPy no attribute called choice. Random dot choice. What are possible things here? 1 to 4. But among 1 to 4 it has picked only one. I want that action number. I'm applying simply in top. It picks only that number 2. So in one shot, at the time of training, the first time, it will take 2 action from the 3. Next time it will take number 4. Next time it will take number 1. Finally, which is best? The algorithm will update the knowledge. Understood my point? So now, to choose one of the possible actions, we will develop one more function. What is that function we will see? First you take this function. Put the heading function for selecting one action from possible actions. Take only this function. Only that's it. After completion of this, all of you take this statement. Available act from a particular state. This line you take it after this function. Completed. Let's execute up to now. Sample next action is the function first. Okay. I'm keeping initial state as 1. Available act. What is our function previously? Available actions. Actions of initial. If I am in number 1, what should be the values of available act? If I am in 1, 3, 5. But among 3, 5, only one value has to be selected. That is what? Action equals to sample next action. Next action of input is available. Same file. Now this time it has picked 3. On that way, what is the training behavior is Initially, your agent doesn't know what to do, what not to do. That is, which is best, which is not best, it doesn't know. Because knowledge is zero. But it performs all possible random actions. For every action, it is receiving a reward. Always it tries to maximize the reward with the help of a Q-learning algorithm, Q-learning equation. Got it? Observe in the beginning moment, for I in range of your matrix, shape of 0. That is all possible states, numbers it is taking. You keep the same thing into here. Available actions. Available underscore actions. Already we developed a function of initial state. Here my state where in the place of initial state I am giving I. After that, what actions it will choose, just observe. Sample next underscore action of a underscore AC. Print from state I. So let's up battery. 1 minute, sir. Battery is going to down. Choose an action. Yeah. Now check the things. In the first shot, 0, 0 to, from 0 to it has selected 5. But 0 to 5 is not possible, right? 0, what is the possible action? Only 4 is possible. But it has picked ACT. There is some mistake happened. Let me check the R value. 0, 0, 0, 0. Greater than or equal to 0.
So for sample next action in dice function, we are passing action underscore.
Even if all the possible actions, but all the available actions are possible, I think it has taken A act. We are passing
So for
A act. From
definition,
the A act,
we are passing global variables, sir, in the definition.
that's why here.
Available underscore act. Yes, down here.
Available actions range. For all the possible actions, we need to pass it.
But choice
There might
parameter, sir. Choice parameter.
pardon?
Choice parameter. np.random.choice, right? There we are passing global variable, right? Instead of range variable.
This available act, okay. This available act is came into A underscore act. Okay, it is taking from this. 1 minute, we will
Sir.
solve it. Initial state 1. Let me check with 0 here. 0 means only 4 is possible, right? 1 means 1, 3 and 5. Okay, that's selected 5. Okay, it is working fine, but here the mistake. next action equals to, here replace that. What are the thing we are passing here? That thing, let's keep it as argument. Possible actions list is here. From that list, picking one random number. Number of random values you can give it. Now again I am rerunning this. Now check the thing. Now check this for loop. If you are in 0, only one possible, that is 4 only. If it is 1, 3, 5 possible. Selected 5. If it is 2, only 3. If it is 3, 1, 4, 5 possible, it selected number 1. Number 4, 0, 3, 5 possible, it selected 0. If it is number 5, 1, 4, 5 possible, it selected number 4. Okay, on that way it will pick it. You just observe. Choose an action from A underscore activity is common list. Correct or not? Take this for loop also. Before that, in the sample next function, please modify this. Take the for loops at all of you. Please don't take outputs. Sir, can I go? Once again, I am running, sir. Try to remember the output values. Any change? Once again. Changing, right? So on that way, like from a particular room, that is from a particular state, we allow agent to perform all the possible actions during training. So finally, after completion of the training, it will understand which is the best. Okay, initially it doesn't know anything, but after training, it knows everything. That is it. But still, our training related program not started. It's a little lengthy. In coming 3 to 4 sessions, we will take it. Till now, you just tell me what are all the things we did. Totally 4 steps we did, sir, up to now. Try to revise. 4 steps we did. First, environmental matrix. But in this program, today program, we created directly. But generally, you get the file in the form of those rules in the form of file. Okay, already you know that process. Second step, knowledge matrix. What is the rule for environment and knowledge matrix? See, size should be same. Initially, knowledge should be zeros. All values zeros. And third step, what is the third step we did? Available underscore actions. That means if you are in a particular state, if you are from your current state, what are all the possible actions that you can do? Okay, so this is for agent you are giving that function. So during training, agent will call this function. Got it. After that, if possible actions are more than one, but agent can perform only one action. How to choose an action from all the possible actions? For that, the second function. The second function we have given sample next action. Got it? Still, don't write this for now. Observe what is this. There is a function called update. Actually, the Q learning equation works in this function. Before going for this function, I will explain mathematics of this Q learning. Understand? This update is a function which updates your Q matrix values. Because initially all zeros, right? This function will update. Once that mathematics completed, I will come to this function. Okay? Okay, this is just a function. Training not yet started. For training, these are the 4 steps. Observe here, very simple. First, you are giving one current state. From that current state, what are all the possible actions? From that possible actions, select one action. Based on that action, update the knowledge. Based on the update, based on the reward received, when our action performed immediately, it gets reward. Based on that reward, it updates knowledge. Within this knowledge updation, there is Q learning equation. Okay, so maybe another 2 to 3 sessions it will take to understand the Q learning and remaining part of the program. Right? All of you till now, whatever the thing is done, please practice. Okay. So holidays announcement for the Pongal festival today afternoon I will give. Got it. Okay, so all of you see in the next class. Till training completed, till it got matured values. You don't know. Because you are a smart guy, it takes only 4 classes to get the knowledge. But there is another guy, it may take 100 classes also. There is no, we cannot fix a rule like 100 iterations, 200 iterations, or 2000 iterations. Understand? But how to identify, how you know that the training is completed? Okay, that is like a policy loss values. Based on the convergence fixed for the class, we can identify that. So those techniques later, once this training part completed, we will see. Right? Yes, Madhava. Surely I will provide because the problem happening is recording the session is half an hour, but downloading, uploading is going to take more than 1.5 hours for me. Okay, so one day in a complete holiday, I will put for, I will sit for only for this one. Okay, same question. Okay, remain people also same questions. Yes, Madhav. Naresh, we can change it. In choice, even one hard coded. Can we change that? You can. Because we need one action, that's why we said one. Suppose you want
Okay,
to allow
sir.
your agent perform 2 actions at a time. Like Rajnikant, left side one gun, right hand one gun, shooting parallelly, like that. think that Rajnikant as a agent. He can do that. At the time, the choice or argument should be number 2. Got it? Huh? It's not for training to select one action. To select one action. That's it. Okay? Sandy has a question here. Sir, can you repeat the session for tomorrow? Also, it's confusing. Definitely, the confusion should be there. Now, for now, imagine yourself as an agent. In the beginning, in the day number 1, you don't know anything. But after you start fighting with this for 3 days, 4 days, automatically all confusions will be clear. And Saimendra Singh. Does anyone how you are getting value from np.random.choice? Simple. You pass any array as argument and give second argument how many values you want. Default is 1. If you don't pass anything, default is 1 value. You want 3 values means you can pass them. Same question, old question by Yashoda. Recordings, about recordings. Already answered. Naresh, in sample next function, is it available act range? Actually available act range. Mistakenly I have written that code. Santosh, can you please post the notepad content? Definitely. Definitely, Santosh. Nandan, good morning. Double good morning to you, Nandan. Yeah. All of you, let's meet in the
Thanks,
next
sir.
class.
Thank you, sir.
Thank you.
Thank you.
Anudeep, sir, can you complete reinforcement learning before Pongal holidays? Never, Anudeep. It's not at all possible. To understand one algorithm, it takes week time. Entire reinforcement learning means maybe by February mid we can complete that. Yeah, stats class we can complete. Now, within 10 minutes, after 10 minutes break, I will go for the statistics class. The same link, sir.